Welcome, class. This is Weather and Climate, Meteorology 10. This is the first lecture in a series of two lectures for this week. So let's get started. All right, so in this lecture, we're going to have forces that accelerate and maintain the wind. We're also going to learn about balances. These balances are going to approximate how the wind behaves in different situations. So we're going to learn about really what causes the wind and how we know which direction the wind is going to go in. Okay, so first, before we start talking about wind and the actual forces themselves, we need to start by talking about Newton's second law. You guys are probably familiar with it. This is going to be where F equals ma. Forces are going to be the thing that accelerate objects. Okay, but the first thing we need to understand is what that word accelerate is. Accelerate is going to be the change in speed or direction of motion. Notice the word change. It's not the speed, okay? It's going to be the change in speed or direction of motion. So those of you that have survived calculus, you know this is the second derivative taken, and you kind of maybe will understand a little bit more about acceleration at this point. Those of you that have not taken calculus, just understand that acceleration isn't the actual speed, it's going to be the change in speed. So if something is traveling at a continuous speed, that's not accelerating. But if you're going from 0 to 60 miles per hour in your car, then that's going to be acceleration. Okay, and we describe acceleration by using vectors. All right, the one thing you should know about a vector is that they have a direction and a magnitude. Okay, so we use a vector to describe it, which is basically going to be an arrow. So an arrow is going to show you the direction by, obviously, the point of the arrow, and it'll also show you the magnitude. The longer the arrow, the larger the magnitude. The shorter the arrow, the smaller the magnitude. We've kind of already went over this a little bit in class for those of you that have had me in class before. So you guys probably have a little bit more of that. I don't go over it as much online here, but just please understand that a vector is just basically going to be an arrow, and the longer the arrow, the stronger the force, and the shorter the arrow, the weaker the force. And whatever direction that arrow is pointing in is whichever area the force is basically being exerted into, or being, pushed into, accelerated. So let's move along. And what I'm going to do is kind of bring you away from weather a little bit and show you an airplane taking off. A lot of us are avoiding these days, but let's just imagine that we're on a plane and we're taking off. Okay, there's going to be a few different forces at work here. First you're going to have lift, basically a force which is going to be in the up direction, upwards in the air, okay, up higher towards space. And that's going to be lift. And that one is going to be counteracted by gravity, which is going to be the force actually pulling you down into the ground. Well, when we're going up in the air, we know that lift has got to be greater than gravity, because otherwise we wouldn't be moving in the upward direction. We would be staying in the same direction. We never really take off. So, and we can feel that, can't we? When we're sitting in our seat, we can feel that upward motion as well as you can when it's landing. Because when it's like, oh, okay, flight attendants, please be ready for, landing or whatever they say. I forget when they're getting close to, when they put down the wheels. You can really feel the fact that you're kind of falling. You kind of can feel that difference between not being lifted up, but kind of falling down or moving down. So you can feel the difference in these, and that's where gravity is actually going to be stronger than lift, is when you're going down. If you can imagine the arrows when you're taking off, the lift arrow would be longer and the gravity arrow would be shorter. You're accelerating in the upwards direction. Now, the other two forces that are at work here, okay, are going to be thrust, which is going to be the thing that's going to push you forward, and drag, which is pretty much an aviation fancy term for friction. Okay, it's going to be the thing that pulls you, keeps you from going forward. So, when things like friction with vectors are talked about, is actually in the opposite direction of the motion. All right, so if I'm moving, if I move this on the desk, I can't show you guys my desk here, but if I have this like notebook and I push it on the desk and it's moving this way, the friction then arrow is going to be in the opposite direction that it's moving in because it's acting to slow it down. It's in the negative direction. So, going back to the airplane has a larger vector or a larger, I want to say magnitude in the forwards direction, the direction is moving in, and it's going to have a smaller vector and the opposite direction is moving in, which would be due to drag or friction. We also know this when we're taking off because we can feel those G's. We're like, on the back of our seat when you're getting taken off. Or even when you're landing because, you kind of have to hold yourself back before, instead of going forward because, you're going, like you're stopping so fast. So if you could imagine these vectors, then when you're going up in the air, when you're going forward, when you're taking off, that vector is going to be super long in the forward direction, whichever direction you're moving in, okay? And that friction or the drag direction is going to be smaller. Okay, now let's think about this when you're actually in mid-flight. So when you're mid-flight, you don't feel any motion, do you? I mean, you can walk around the cabin, you can use the restroom without falling over, I guess. You can hopefully pass by people and not fall over. That's because all these forces are equal. Okay, that doesn't mean you're not moving. You're still moving clearly at 500 miles per hour, I think is what planes usually move at. So that doesn't mean you're not moving. It just means that all of these forces that we have going on are going to be equal. There's engines that are actually pulling you, keeping you up, keeping that lift going, okay? The wings, and I don't really know a lot about aviation, but there's something pushing you up that's going to be equal to the gravity. Equal to. Okay, that means that these forces actually add up to 0. So lift and gravity when you're in mid-flight are going to add up to 0, meaning that they're in balance. When acceleration, when these two vectors are in balance, then that means there's no net acceleration. Oh, here's Argos. He decided to come say hi to us. Come say hi to everybody. Come say hi. Here's Argos. Yes, he needs to be groomed, but there's no groomers open, I would assume right now, so he's not getting groomed today. Anyway, okay, so we have this plane. All of the vectors are, even the front and the back, so the drag and the thrust are going to be equal. The vectors are going to be the same length. Okay, they're going to add up to 0. We have no net acceleration. Everything is in balance. That doesn't mean it's not moving. I really want to kind of drive this home to you guys so you understand that doesn't mean that the plane is not moving. What it means is it's not accelerating. Interestingly enough, human beings actually can't feel speed. They can only feel a change in direction. So that's why when you're on this planet and the planet is spinning around on its axis, you don't feel like you're spinning around on an axis. You feel like you're standing still. That's because there's no acceleration. It's at a constant speed. If you notice when your car is going 60 miles per hour and you set your cruise control, you don't really feel like you're you don't feel anything pulling you back into your seat or anything. That's because you're in constant acceleration. So pretty cool. But what does that mean about the wind? Okay, that means I already kind of went over this, if forces are not in balance, the air parcels will accelerate. I already went if they are in balance, they will not accelerate, right? That plane that's moving in the air and it's not doing anything, it doesn't feel like actually it's doing anything. It actually is. It's moving forward. It's getting us to our destination, right? But if they're, with that flip side of that, means if they're not in balance, that means the air parcels will accelerate. So if we go back to that first screen, here, remember I said that the vector would be longer in the up and in the front direction, and it would be shorter in the down and in the back direction? They're not in balance. So it's accelerating. Pretty sweet. All right, so these are going to be the group questions. Those are of you that are new to the online experience. I always encourage you to pause at this point in the video. Please try and answer them.